So, good evening, and thank you for joining us for this online event arranged by the IMechE Automobile Division Yorkshire Centre. My name's David Bryant, and I'm the chairman of the centre and will be overseeing the event this evening. We've been hearing a lot in the press recently about the rapid growth of Arrival and its innovative manufacturing processes. And judging just from the number of registrations for this event this evening, there's a great deal of interest in the company. So it's my pleasure to introduce Nick Clay, Head of Product Compliance at Arrival, who's going to tell you more about this story. Now, Nick joined Arrival in 2016, having spent time at the VCA working on type approval, and then at Thatcham Research heading up Euro NCAP testing and development. At Arrival, Nick leads product compliance across the company's wide portfolio of products, from buses and vans to batteries and robots. Through the event, if you have any questions for Nick, then please post them in the Ask the Questions tab during the presentation, and we'll endeavour to answer these at the end of the presentation. So, without further ado, I'll hand you over to Nick.
Oh, lovely. Thank you very much, David. Can you hear me all right, David? I think if you can hear me, everyone else can as well.
Yes, I can hear you loud and clear.
Perfect, lovely. Thanks very much. So, yeah, it's a shame I can't say it's delightful to be in Yorkshire this evening. As a guy who was born in Sheffield, it would have been great to come back to my home county or my, maybe even my hometown. But I was looking back, and Alok from the Yorkshire Centre first messaged me back in January last year. Although it seems like a hell of a lot longer ago than that, given the year that everyone's had. So I just want to say well done to everybody who's here tonight and has made it through the last year. Hopefully, the coming 12 months won't be quite as crazy, and maybe I can come and see you in 12 months' time in person. So, as David says, if you have any questions as we go through, fire them into the panel on the left-hand side, and we'll go over those at the end. So, how it all started for me and how it all started for Arrival is probably a relatively I'll keep it relatively brief because I don't want to take up too much of the interesting information from later on. But back in 2016, when I was working for Thatcham, we went out to see Tesla to talk about the Euro NCAP roadmap and sort of Tesla's driving assistance sort of technologies. And they were showing us around the factory, and they said, back in 2008, this was when we took over, this was an empty sort of mothballed building, and they'd taken over from GM Toyota in the who'd sort of vacated it in the financial crisis of 2008. And I sort of scratched my head a little bit and thought, I can remember back, what I was doing in 2008, and I can just about remember what I've done between 2008 and now. And, Tesla have gone from this big empty building to, at the time they were churning out 50,000 cars a year. The Model 3 was about to be released, and they're about to, go on this sort of rapid production hell, as Elon calls it, up to 500,000 vehicles a year. And I can remember saying to myself then, if I ever get the chance to do something like that, I'm gonna jump at it and try and be a part of it. And it's probably about 3 months later that I got a call from a guy I'd been on a graduate scheme placement with. And this was at TVR up in Blackpool, and I met a guy called Ben Jardine who joined Arrival a few months before I did, and gave me a ring and said, "Oh, we're looking for someone to do homologation and quality for Arrival. Do you want to come and see us?" So I went and had a chat with them, and it seemed like a good idea at the time. So I decided to join them, and because they said, "Oh, we're going to be the Tesla of trucks." And probably within about a month of me joining, Elon Musk had come out and said that Tesla were going to make trucks. So we couldn't be the Tesla of trucks anymore, but it at least cemented my view that I'd made the right leap at the right time. So I've been with Arrival since August 2016, and I was I think I was number 37 or number 38 in the UK. And at the time we had about another 30 people in St. Petersburg in Russia as well. And we're now up to, as of this week, I think we're pretty close to 1,700. I can tell you exactly if I just check my messages. 1668 in total globally. The majority of those are probably a 50-50 split between the UK and Russia, with a few hundred spread globally. So we've now got probably 20 people in the US, and probably another 30 or 40 people in between sort of Germany and the Netherlands as well. But we're growing rapidly, and I think even since I spoke to Alok back in January last year, we've added, we've probably gone from 800 to 1600. So we're going through a fairly rapid expansion as we move on to our delivery phase, which is what I'm going to tell you about tonight. So Arrival was started back in 2015 by a guy called Denis Sverdlov, who made a hell of a lot of money in the Russian telecoms industry, and decided that the commercial vehicle industry was ripe for disruption, and started with what now is a really, really rare opportunity, and with a completely clean sheet of paper. There was no legacy of suppliers, there was no legacy of production methodology, there was no legacy of buildings and production lines, there was no legacy of staff. It was a complete clean sheet of paper to design and build electric vehicles that could make an impact environmentally the right way. And I can remember back, I think it was the first meeting I had with him in probably September or October 2016, and he said he wanted us to be a $10 billion company. And at the time, to me, I did mechanical engineering at university, and I'd been in the civil service and then working sort of for Thatcham and Euro NCAP. Back in 2016, those were some pretty big numbers, and I can remember thinking, crikey, this guy's, he just said it with a confidence and an air of knowing what he was talking about that you didn't question it. And sort of 4 years later, we're here with what was an initial market value of 5.4 billion, but looks like we'll actually be going to market close to 20. And it's been a crazy few years. So I'll talk you through what we've been doing and how we've been doing it. And there's a slide at the end for if anybody's got any interest in becoming involved in what we're doing. So we're set up to revolutionise the electric vehicle industry, and it's that clean sheet of paper that we started with that's really enabled us to do that. So our first 4 vehicle designs that will come to market between now and 2023 have already generated $1.2 billion in orders. So that's, in terms of volumes, that's about 20 to 30,000 vehicles in volumes. And we're focused on the commercial vehicle end of the market, which is a really difficult area to focus because the volumes are a hell of a lot lower than they are with passenger cars. So, whereas passenger cars, you could reasonably expect to be in the hundreds of thousands and set your profitability levels there. With commercial vehicles, the volumes are a lot lower. The global market for buses is in the low thousands, not the tens or hundreds of thousands. So you really have to make sure that what you're doing is financially viable and that you have a production methodology that can support that. So that led us to the microfactories approach, which I'll tell you a bit more about as we get further on. But one of the key things that Denis wanted to do is he wants to make an impact. And, so as Arrival, sort of deep within our DNA, it's how can we deliver electric vehicles that make an impact to the environment and to people's lives and solve mobility problems that exist all over the world at the moment that, the current industry just isn't set up to solve. And one of the key things about that is being vertically integrated, which means that the majority of our core components we develop and manufacture ourselves. So where the current industry is probably at a state where the majority of stuff is bought in from tier 1 and tier 2 suppliers, that generates a lot of cost. It generates a lot of timing issues. It generates a lot of risks for all the parties involved. When you bring all of that in-house, it gives you a lot of flexibility. So the batteries that we make, the motors, the gearboxes, the inverters, the ECUs, the control units are all Arrival products that we manufacture ourselves, or that we design, develop and manufacture ourselves, that go into our vehicles. And that's one of the things that will help us get to market as close as we possibly can to price parity with conventional vehicles, and with no compromises required to do that. So, the aim is you'll be able to buy an Arrival van for the same price as an equivalent diesel vehicle and not have to sacrifice anything in terms of load carrying capacity or safety or vehicle performance. So our main talent guy, kill me if I didn't point out, we were named #1 startup to work for in the UK in 2020. the cynic in me would say that that's because we do Arrival look after us very well, and so we get lunches and food and drinks, and there's always a free bar at the Christmas party, which helps a lot. Just wait for the slides to tick over. The thing about when you're working in sort of small organisations and startups, whenever someone big comes along and validates your idea and says, no, what you guys are doing is the right thing, it's always hugely important. And back in 2016 when we first started, we were engaged with UPS, and even from the start, UPS were incredibly excited by what we're doing and brought people over with from their main. UPS are based in the US, in Florida, and their main global vehicle design team and global vehicle chiefs will come over on a fairly regular basis, and they were our first strategic order and have also invested in Arrival as well, but have been sort of with us on this journey from the very start, because ultimately they saw that they wanted to change what the industry was delivering to them as a huge user. So they have about 180,000 vehicles globally, and they picked up that that's 180,000 vehicles that ultimately are going to have to go electric, and they want to make sure that those vehicles will go electric in a way that lets them continue to operate as they need to deliver the service that they do. So it's a great fit for us as a sort of strategic partner, and validated what we're doing as well, along with the investment that we got from Hyundai Kia last Christmas, which was fortunately for us was confirmed what in the olden days would have been live by satellite link, but at the main Arrival Christmas party, Dennis came over on I think it might have been a Facebook live chat from Korea to confirm that they just signed the documentation with Hyundai, and that Arrival was officially a unicorn, which, as you can imagine, not many people can remember much of the evening after that, but it was a really big moment for us, and again, validation that what we were doing was the right thing to be doing. And that relationship with Hyundai Kia has developed further, and we've got quite a few vehicle programs in development with them now, sort of moving forward. So it's quite a fruitful relationship. So, what we're aiming to deliver is best-in-class zero-emission vehicles, and we're a lot of stuff in the automotive industry, and almost in any industry, is always about timing. And we're relatively fortunate, I guess, in that we've managed to be at this sort of peak point of public awareness, of government drive, of environmental support, of general, I think, organisational support from the large sort of blue chip companies, who are now starting to realise that customers want them to be environmentally friendly as well. So we've sort of fortunate in that we're coming to the market at exactly the right time, but we also know that we need to be competitively priced to match conventional vehicles, because otherwise the transition just doesn't work. If you're any size of fleet and you need 20, 30, 40 vehicles to deliver that, to deliver your service, you can't do it if you've only got a budget for 10 vehicles, because the electric vehicle is twice as expensive. So getting that competitive pricing down is the key to adoption for us. We've also going down the route, as you'd probably expect from a modern company starting from a clean sheet of paper, of hardware and software upgradability over the lifetime of the vehicle. So where we can engineer out hard switches and hard points, and engineer in components that can be controlled by software to deliver features that you can upgrade over time. That's going to make a big difference for residual values of vehicles, which drive fleet pricing, which drives the ability of fleets to transition quickly. We're also developing autonomous vehicles. I've got a video later showing sort of one of our autonomous vehicle projects that's up and running at the moment. But all of this isn't possible without really sort of tearing up how you do stuff. So, the conventional manufacturing methods of body in white and the sort of the huge panel presses and stuff isn't where, Arrival's vision is enabled to be delivered. We had to come up with something that was different. We had to come up with a composite material that was lighter, so saved the weight, which meant the additional weight of batteries was offset. We had to come up with a manufacturing process for that we knew was scalable, that didn't use huge amounts of energy and required huge tooling costs, so that you could be flexible and open these micro factories sort of as and when they were needed, but also be able to scale up and scale down depending on demand and sort of economic situations. But you also need to then make sure that as a vehicle you're successful to be able to carry on doing those. So by engineering the cost out of the vehicle where possible, you can make up for the fact that the battery is the most, probably the most expensive component of the vehicle. I went backwards by mistake there, I do apologise. So there's some key industry trends going on. You'll all be aware that the UK in particular has announced that by 2030 all cars and vans have to be zero emission. Buses have actually been transitioning a lot earlier, but there's a big push with the government's electric bus projects to move to that. But all in all, what this is doing is sort of rapidly growing the totally addressable market for electric vehicles without actually there necessarily being the supply there at the moment. So it's creating a bit of a vacuum which Arrival will be running into headlong. What electric vehicles let you do as well is, the big advantage for fleets and the big attraction, I guess, that a lot of the big, our big potential customers like UPS see, is that you can drive down the total cost of ownership. You're heavily reliant on the price of electricity, but there's a big shift going on there as well with a move to green production of electricity and, the CO2 impact of that coming down massively as well. And, there are some markets where it works better than others, but, even those markets are moving towards greener electricity production now. But by getting the vehicle right and combining with infrastructure, so we've got an energy team who are based out in Israel producing charging systems for vehicles to make sure that the same approach we apply to vehicles applies to infrastructure as well, so that fleets aren't tripped up by expensive infrastructure costs once they've decided to make that transition to electric vehicles. Optimizing the energy efficiency is crucial, because I think as we move forward, CO2 is the main taxation point at the moment, but ultimately the government are going to have to, and governments all over the world, they have to replace the revenue they get through taxation of CO2 with taxation of energy. And so, the more efficient you can be now, the better position we're going to be in the future when that does happen. So a bit more about our next generation vehicle. So the Arrival van, this is the beta van. So the Arrival van that you'll have, the Alpha van that was probably around at the start of last year, you might be a bit more familiar with. That's sort of the flatter fronted vehicle, but we went through a really heavy period of engagement with a lot of key stakeholders last year, and really, really big sort of fleet customers who were, who have fleets of hundreds of thousands of vehicles. And, the answer, or the push we were getting from them was that, the economy for the people who drive these vehicles is changing as well, and they're sort of rapidly becoming used more by car users, but for an alternative source of income, not necessarily by, I guess, what you class sort of dyed-in-the-wool commercial vehicle drivers, as they perhaps would have been 5 or 10 years ago. And so what they want is passenger car levels of safety. And so what moving to this sort of slightly more conventionally fronted van let us do was actually massively increase our safety levels. So we could be able to offer passenger car levels of safety rather than good van levels of safety, which was the level we were at before. If we go into van levels of safety, it's quite a complex scenario. They're not really catered for in any of the crash regulations or consumer crash schemes, but it's a really difficult problem to solve. So, we base ourselves on the car crash requirements and sort of move from there. So the Arrival van is going to, where we're targeting and where we are at the moment is to deliver a best-in-class experience across the board. So, making sure that our unladen weight lets us give a payload which is equivalent to our competition or better. Then quite often we end up getting helped out by schemes. So at the moment in the UK, they've just brought in an exemption to let you drive an electric van up to 4.25 tons instead of 3.5 tons. But given that we were aiming to be competitive on payload at 3.5 tons, actually at 4.25, it means we're way above what the competition can be, which then actually gives gives fleets the opportunity to actually potentially come down from bigger, heavier vehicles that they were driving before into our vehicle, because the payload is such that they can do that. A lot of key things that logistics providers want is a turning circle, curb to curb, that is as small as possible, and we're way under what the competition can do. And the same in terms of the cubic meters of cargo volume and the gross vehicle weights as well. So I'm a compliance guy, so homologation is my key bit. So the key things that we're looking at are 3.5 tons, because that's at what point you stop being a light commercial vehicle and turn into a heavy commercial vehicle. And the 4.25 ton puts us into the heavy commercial vehicle bracket, which has a slightly different set of regulations to it. But that's where we're pinning ourselves. So some nice pretty pictures. So inside the vehicle, you'll note sort of simplicity is the key at arrival. So van is the product name that we'll be using in the market, and that simplicity sort of carries through into pretty much everything we do. So our interior, the way things work is all about simplicity by, I guess, engineering out complexity where that complexity leads to cost. There are areas where we are relatively complex, but it's through a real necessity to be complicated there, rather than a complicated design. An example of this is probably our rear light clusters, which you can see in the bottom left picture there. So they're relatively special and something we've not come across before in the market, in that it's one unit that flips over to form the right hand. So the left hand light cluster flips over, and there's also the right hand light cluster. So rather than have two sets of tooling costs and two sets of production costs, actually it's a single unit that is just used repeatedly. And the same unit is on our bus as well as our van product, and on our bigger van products as well. But by spending a bit of time and making sure that it worked in that mirrored situation, we were able to actually make some really significant savings on down in our supply chain on the tooling costs required to deliver that. So moving on to the bus. The bus is going to be the first arrival vehicle into production. Globally, there's a totally addressable market of 131,000, but that's buses globally in total. So actually, when you get down to the UK market, there's probably about 1,200 electric buses a year. So with our sort of micro factory concept, that's what we're looking to service in the UK, and then we put a micro factory near to where the demand is for all of these vehicles. But it's a modular bus, so it's made up of 1.5 metre sections with a 0.75 metre section at the front and rear, which lets us turn a 12 metre production bus into a 10.5 metre or a 13.5 metre relatively straightforwardly, just by removing sections from the centre. And as with the van, simplicity is the key for our designers again. So none of our design team actually came from automotive backgrounds. They all came from industrial backgrounds, which is a relatively interesting fact. So again, the bus aims to be best in class, but I won't hang around too long on these ones. We've got quite a few slides to get through, and I don't want to keep you too long. So in terms of our timeline, so bus goes into production at the back end of this year, followed by van probably middle of next year, fingers crossed slightly early next year, and large van towards the back end of next year. And then we've got a small vehicle platform coming midway through 2023, probably maybe towards the end of 2023. But again, focusing on the commercial end of the market rather than probably a direct-to-consumer model at the moment. And then what that lets us do is it lets us get confidence in markets, because we can go in and service large fleets, which then lets us build up our market presence before we then sort of open sales to the rest of the market. So our new production methodology that we talked about. So one thing that Dennis says on a really, really regular basis, we see him a lot. He's in the, when we're not fully locked down, he's in the office most days of the week, and in the factory a lot as well. We're not an OEM, and he's adamant we do not want to be an OEM. We don't want to get caught in a lot of the same loops that a lot of new startups have been caught in, but a lot of the old existing startups have been caught in, where they end up weighed down by decisions they've made on supply chains and production methodologies and legacy and stuff. But he wants to be a technology company where we can be nimble and where we can alter our direction quickly and easily. And one of the things that lets us do this is the sort of 3 core principles of plug and play components. So by having components that are produced on a grid system, so everything is produced in multiples of 10 in terms of, sort of dimensions, it lets us substantially reduce costs because we can apply these across all our vehicles, and from a packaging point of view it's incredibly straightforward. It also makes it very easy to upgrade components, and they're designed to be built in micro factories as well, so it lets us drive them to our products quicker as well, but with the flexibility that we can place those micro factories in markets where the demand is. Composite materials we talked about is low tooling and overall cost. It's lightweight and highly durable, so it means that from a fleet point of view, your total cost of ownership reduces, and the lightweighting helps us deliver the probably best-in-class range, as well as making sure the payload is available for customers as well. And it's all that fits into a modular skateboard platform, which there's not many people who don't have a platform now. Our platform is a lot flatter than most, so I think we've got a couple of images coming up which will show that. So the micro factories have a low footprint, so we're on 10,000 square meters, which will let you kick out 10,000 vans a year, or 1,000 to 1,500 buses and trucks. And then we use all of our own in-house software as well, so we've got plug and play software, and that lets us completely control the user experience and makes the integration a lot easier. We're not trying to we're not trying to integrate a tier 1 supplier's parts and components and software with our own software, so it makes life a lot easier. There we go, and here's our prototype robot cell in action. So we take robot arms from Comau and KUKA and then strip out their internals and put our own in terms of control systems and architecture for them, and then sensors that let them sense what they're picking up, so they can pick up any part and it doesn't have to be handed to them by a jig. So this is our van micro factory, which is in Bicester. So I don't know whether many of you know Bicester. It is home to a large outlet shopping village, and also Arrival's first UK micro factory. So this is the van micro factory, which is the building in the foreground, and then composites will be built in the building in the rear. And this is our Rock Hill bus factory in South Carolina in the US. The beauty of our approach is that we go into existing buildings, so we don't have to purpose build a huge production facility which takes 2 to 3 years and costs billions of dollars. We can be in a building and have it fitted out probably within 6 to 9 months for probably about a $20 million cost in total. So there's a bit more detail. We'll skip over that there. So again, versus that traditional approach. So if we look at the Arrival van factory, the capital expenditure is so low compared to what it would cost to scale up a van factory, is crazy. And I think that's what attracts a lot of people to our approach, because it means that we don't end up with this huge legacy that when the market changes in 5 to 10 years time, is actually going to be a liability on your balance sheet instead of an asset. And so I mentioned our plug and play components earlier. So these are our high voltage battery modules, which are designed and produced in-house. And they sit together in the platform of the vehicle, which sits under the van and also under the bus. So they sit in the floors of both of those vehicles, which is ultimately the most sensible place to put them, because we didn't have any legacy of having a chassis and lots of complex engineering under there, which has led a lot of current market entrants to put them on the roof of buses is most common, for example. So this is the van platform that we talked about. So the drive from the start from all of our customers, they wanted as flat a floor as possible. So where they have the logistics guys who are climbing in and out of vehicles dozens of times every day, they wanted to make that transition from front to rear as low as possible. So that drove push to get as much as possible into the floor of the vehicle. So it only raises up behind the or in front of the front wheels, and that's so that we can incorporate the crash structure. But beyond that, it's a completely flat floor vehicle, which means that people can walk through the bulkhead door and just totally removes the number of steps that give risk for fleet operators every time their drivers are using them. So there's the amount of sick days that current fleets have from drivers injuring themselves getting in and out of vans is phenomenal. There we go. So a bit more on the composite materials. So the reduction in tooling costs is massive, but it's also a low energy process. So it gives us a shorter tooling time. It gives us ability to scale up to whichever market we go to. So, as you've seen in Vista, we have two facilities next door to each other, and both of those can be up and running in sort of 6 to 9 months. But it also lets us, because the tooling costs are so low, it lets us make changes to meet customer demands pretty quickly. So where perhaps the top hat that sits on top doesn't quite suit the customer's needs, it lets us actually make relatively quick changes relatively easily, especially compared to sort of conventional vehicle manufacturers where you're looking at sort of stamping and sort of tooling costs in the millions. So here's 2 panels. Alas, I've not got the video for this, but these are 2 panels that have been driven over by a large truck, and the composite body panel didn't show any damage, and the steel body panel, as you'd expect, shows a lot of damage. So arrival is, as I mentioned earlier, so we've got 1,600 people now, or 1,660 people now, and we're probably a 50-50 split between software guys and hardware guys. So, and the split is probably, most of the software guys are based in St. Petersburg, which is where we've got a huge sort of software operation, and most of the hardware guys are based in the UK. But what that lets us do is it lets us build out an ecosystem for fleets. It lets us build out an ecosystem for drivers. It lets us control all our vehicles and puts all of the control of that data in our own hands as well, which gives us a lot of opportunity for vehicle improvements, for giving additional services to fleet operators that at the moment they have to buy 3 or 4 different systems to be able to deliver. Right, and so all of as with every tech company, you'd expect us to have a reasonable portfolio of IP as well. So we've got loads of IP and patents around BAN innovations in how the vehicle is built, some of the features that we have, some of the complexities around our motor and gearboxes, around how we get the inverters delivered for the cost we can deliver them at. And that sort of stuff. So really, sort of across everything, it's when you're a startup looking to generate generate value for investors and stuff, intellectual property is where is one of the biggest things you can be involved in. So what all our investors are looking for is how much of this IP is actually yours and how much of it is valuable. And so that's a huge sort of due diligence loop we go through with all of them. So the main benefit of our new method is it gives us this sort of distributed production. So there's a lot of talk at the moment about decentralizing, and sort of one of the things that Industry 4.0 lets you do is do that without having a huge burden of a workforce in the tens of thousands. And nobody likes reading the stories about how various manufacturers are having to get rid of tens of thousands of people at a time, and it's because ultimately you can't scale down quickly. Where you've got without a huge societal impact, unless you've built your business to be able to do that from the ground up. And so what that lets us do is it lets us put factories in local markets and provide jobs in those local markets, but it also then lets us develop vehicles that are more specifically suited to that local market. So while the platform is the same, what sits on top might be slightly different. So the bus is a great example of this, where what works in the UK and Europe for a bus is slightly different to what works in the US. So the US bus is slightly different. and the same for in India, but and other developing markets like that, where they have slightly different sets of requirements. The regulations aren't as tight or are slightly different, and it lets us make those changes relatively quickly and relatively cheaply to be able to service those markets. So just have a quick look at what our competition are doing and sort of where we are. And I guess one of the reasons why I guess the big institutional investors are so keen on Arrival is, you know, in terms of where we're going and in the size of where we are now compared to where we've come from, we're probably streets ahead of a lot of our competition who, when push comes to shove, you quite often see that they're relying on technology sharing agreements with actually a lot of the existing OEMs already. So, you know, we're pretty unique in the fact that absolutely everything comes from in-house. So, you know, we're not relying on anybody for anything. And the relationship we've got with Hyundai Kia is very much our technology to them relationship rather than us bringing anything in-house from them. So a bit more. If you look at our market value in terms of how it's assessed against a totally addressable market and our sort of proposed sort of multiplication factors, it's incredibly attractive, which is good for us because as I mentioned before, Arrival look after their employees reasonably well. So yeah, it works out quite well for everyone, hopefully. So the opportunities we've got as we move into the future are sort of further vehicles coming off our platforms, as you'd expect for a technology company. So RoboRace is our one of our sister companies in our group, and they've developed our autonomous vehicle software from the ground up, as with everything else we've done, and that's now leading on to our road vehicles as well. So we've got a couple of autonomous vehicle projects. I'll tell you a bit more about one of those in a minute. And you know, we end up building out products that are being built to service our own products, but actually then have value in the market as well. So our software as a service platform actually can do a lot of stuff, not just for Arrival vehicles, but for other companies' fleet vehicles as well. And then the slightly left field one is emissions credits. So in the US, most of you have read that, you know, Tesla partnered with Fiat Chrysler for selling a lot of their emission credits, but it actually as a startup gives us a really great income stream to do that we can then reinvest in more micro factories and rolling out electric vehicles to the market a lot quicker. So we're starting to look at that process in Europe, where it's slightly different, and the European targets for reducing CO2 in vans are a lot lower than they are in the US. But there's a demand there for credits, and you know we'll be able to service that hopefully. So that's good. So I mentioned RoboPilot earlier. So this was one of the first things I did when I joined Arrival in 2016 was Dennis said that we should keep up to date with what NHTSA are doing in the US for putting autonomous vehicles on the road. So NHTSA just put out a framework that said, oh, if you want to test autonomous vehicles on the road, you need to do X, Y, and Z. And about that sort of time, CCAB in the UK brought out a funding call to look at putting autonomous vehicles onto the road in the UK. So we applied for that and partnered with UPS and a few other organisations. So Thales were looking at cybersecurity, some lawyers, as you'd expect when you're doing things that nobody's done before. It's always good to have lawyers involved. There's an insurer involved as well, and the University of Bristol and University of West of England, who've got Bristol Robotics Lab to do a lot of the validation work, and then Loughborough University, who did a lot of the safety research for us. So that project ended up starting 1st of January 2018 and comes to an end this year. And there's two main streams to that. One is 10 miles of on-road driving, and then the other one, which is probably the nearer term bit, is the depot autonomy side, which is actually taking the driver out of the equation in a depot scenario, which is a really nice one because it's off-road, so it's out of the realms of sort of Department for Transport and stuff and into the realms of health and safety, where actually autonomously moving vehicles are a lot more common. It's a huge benefit for big fleets because actually a lot of their low speed but high value accidents that they have are within the depot environment, be it knocking wing mirrors off or, you know, minor dents, reversing vehicles and stuff, because that's where the majority of the sort of small vehicle movements are made. But also it means that they don't need to employ people just to move vehicles around from loading bay to loading bay. You know, actually that can be done autonomously. So it's potentially a huge value, which to have that value stream there and defined is great when it isn't necessarily there for, certainly for level 4 autonomy yet, where you still need to have a driver in the vehicle. So, you know, there's a safety benefit, but not necessarily a financial benefit, which is ultimately what drives the majority of technology. Lovely. The first development of this was just before Christmas, when we commandeered the UPS depot near Bristol, which is where I'm from, for our first demonstration of autonomous depot movement. So there's a couple of key things in here. They always sound the horn when they're driving in, so we've got a delightfully sounding prototype horn that I can't hear this, but you guys should have heard that already. But we ended up having to make some modifications to make it a bit quieter, because it got to be at a point where it was really intrusive. But this is our really early alpha prototype van, so fully equipped with LiDAR, radar, and ultrasonics and camera systems as well. And so we're sort of testing out various manoeuvres in the UPS depot to make sure. And one of the key things that UPS wanted was to make sure we could get within 50 millimetres of the loading bay consistently. Mainly because this reduces the risk of trips and falls between guys getting in and out of the vehicle when they're loading it up with parcels or taking parcels out, which happens on a fairly frequent basis. So we haven't made a lot of this footage public yet, but it will come out probably March, April time, when we've got another filming event to catch up and get some drone footage. There we go. So just to, I guess, summarise everything before I've gone slightly longer than I wanted to, but it's not too bad. So our first vehicles end up in the market later this year, hopefully with bus, and then early next year for van. And we've done this by, you know, engaging with our customers from a really early standpoint to make sure that we've got the orders to lean on to give us the confidence to proceed in what we're doing. And actually, by being bold and doing something that nobody else has done before, it's worked really well for us, and actually has gained us a lot of support, both with conventional manufacturers like Hyundai and Kia, but also with I guess the financial institutions that ultimately will A, invest in us, but B, end up doing things like supporting fleet purchases through leasing systems and stuff like that. We're incredibly vertically integrated, which is the way we're managing to hit our cost targets. And you know, we've had that validation from our strategic sort of blue chip partners as well. So yeah, all in all, it's been an it's been an exciting 4 years for me, and 4.5 years for me. I'd like to sort of stretch it out a bit more, but ultimately we've been sort of working in these sort of 6 to 12 month sprints, because we've always been aiming sort of 12 months ahead. So what we've never wanted to do is hold ourselves and say, right, we've got 2.5 years until we get to production, because we wanted to maintain that sort of speed and flexibility that, you know, technology companies have, but OEMs don't. So you know, that's what's driven us to do that. So, you know, you sort of look back at 6 months ago, and it wasn't too different from the 6 months we had before that, ultimately, which is you know, which is what keeps it fresh and exciting for, you know, for all the guys who work here, which is good. And so to preempt a question that may well come, Arrival hire on a weekly basis. We have, you know, anywhere between, I guess, 5 and 20 or 30 people starting. So I will flash up our email address for employment opportunities. We don't necessarily advertise opportunities, but we are looking for, you know, any number of roles at any one time. So, you know, if you drop a note to talent@arrival.com, they'll get back to you and let you know what's available. Which I think just about brings me to an end. And hopefully, are you still awake, David? Oh, he might be, might not be.
No, I'm still awake. I couldn't find the unmute.
Okay, no worries. Excellent.
Fell into the standard trap of online conferencing. Well, thank you very much, Nick. It's been a great tour around, Arrival's story up to now, and also understanding where Arrival wanted to be, like the Tesla of trucks, and where they are now, and also where you intend on going. So it's really, really nice insight there, and you've given some nice snippets of information there. And seeing some of the questions that come through, I can see that you've got people thinking.
I think I didn't even get to cover the Charge Mustang project, which is the probably from a driving point of view the most exciting one that we've got, because vans and buses aren't known for their sort of handling and drivability, but they're Charge is a sister company, and that's probably one of the certification programs I'm looking most forward to.
Yeah, I'd noticed that on your website, and it adds sort of extra bows to your string, really, doesn't it? Or extra strings to your bow, even. And
we can maybe do a separate whole session on that one. That's a really, really interesting project that sort of marries the oldest and the newest technology there is.
Well, we might hold you to that one then. I'll let you say that. Right, let's start on some of the questions then. So I'll work through the ones that have been coming through. Possibly a little bit related to your last comment there about the Mustang project and other areas where you're applying your technology. So have you considered the market for converters of specialist vehicles such as motorhomes and horse boxes and similar vehicles?
Yeah, we do. So the van will also spurn a chassis cab derivative that can have a box put on the back. We're also looking at, we're working with a couple of, I guess, of the specialist converters out there who would do stuff. The worry about the conversion market is they aren't necessarily as aware of electric vehicles as they perhaps need to be, and it's a big change being able to drill into the floor with anything you want to not being able to drill into the floor under any circumstances, because you'll end up in a high voltage battery pack. So there's some controls that we're sort of looking to put in place, but we're working with quite a few, I guess, sort of second stage converters as we would call them. To make sure that, because it's like, as you say, it's a big market, and make sure that we can support that as well, because things like tippers and drop sides and horse boxes and stuff like that are ultimately need to transition to electric as well. So
indeed, yeah, and you're ready placed to be there, aren't you? Yeah,
indeed.
Okay, so moving on to the next question. So, do homologation rules limit the ability to apply software updates?
Not currently, but from 2024, there's a new regulation coming in that will require certain processes that you have to go through to make sure that your software update still keeps you in compliance with the homologation requirements and stuff. So at the moment, no, but in future, yes. But we're applying that to ourselves, from day one. So just because it's easier rather than trying to bring it in later, we've set ourselves up to make sure that those processes are in place now.
Mm-hmm. And I guess your updates, they'd be over-the-air updates, would they?
Yeah.
I guess the intention to keep the vehicle on the road as much as it can, which is essential for the commercial vehicle market. Yeah.
Yeah.
Okay. So possibly someone looking for a sale here. So is there intention for the van to be sold to consumer customers as well as commercial?
Yeah, it will. Yeah. So I think, I'm not sure whether it's from day one. I think from fairly early though, we'll open up sort of direct sales to consumers as well. But what we wanted to make sure, I guess, as an organisation, was that we had that volume of fleet sales to be able to support factories in markets and stuff. So What we we've decided we definitely won't be doing is allocating an entire factory's build to one or two fleets who've got big orders. So it'll be if we've got a 10,000 capacity factory, there'll be a portion of that that's not allocated to big fleet contracts and stuff as well, just to make sure that the entire market gets serviced and not and people don't fall behind.
Mm-hmm. Yeah. Okay, so if you are an owner operator, there's
it'll be much when you buy a Tesla today.
Okay, next question then. Commercial vehicles traditionally require lengthy durability test programs. If you're planning on production later this year, how far through your testing are your prototypes, and what's your durability objective in miles or kilometres? Give as much detail as you can there.
Okay, so we've just started our full vehicle test programs now, so that'll ramp up to sort of the peak of activity probably the summer of this year. Ultimately, on an EV there are a lot less moving parts, which does make life a little bit easier. But we're looking to do we've got a hell of a lot of simulation capability, so a lot of what we're actually doing is gathering data to feed into our simulations to help us get ahead of the game. But there'll be an element of making sure that we know the answers at a certain point before we actually go into production, but there'll also be an element of catch up afterwards, I think, probably.
Mm-hmm.
But the good thing about working with fleets is exactly what they're going to be doing with them, so you don't our first customers are going to be fleets who use their vehicles and are primarily based in depots, so actually the vehicles are going to be driven in an urban area every day and parked up at night. You don't have to worry about the guy who's going to go and go and walk his dog on the beach and park his vehicle on the sand at Weston-super-Mare and stuff. And likewise, the guy who's going to take it on a road trip to the Alps and stuff like that. So we can be pretty focused in what we do, which helps us get to market quicker. But all of their durability work will be a mix of simulated work that we've gathered a load of real world data to support, plus the more traditional durability work that goes on at the same time as well.
Okay. Next question relating to buses. So can you achieve a low floor bus requirement with the batteries underneath? As you mentioned, some of the competitors with traditional methods putting the batteries on the roof. And will the buses kneel for the disabled access?
So basically, through kneeling we can meet the low floor requirements, and we're just under the low floor requirement for when you're not kneeling. So just is the answer to that one. That was the main driver for the height of the battery pack.
Mm-hmm. Okay. Right, we've got a question from someone local to Yorkshire here. So figures you demonstrated in your slide for the range of vehicles, how accurate are they? And since you said you're from Sheffield, how will the buses cope with a full load on Jenkin Hill or East Bank Road? And how long does it take to recharge? Testing your local knowledge there.
So the name of this guy sounds really familiar as well. So all of our range at the moment is simulated range. So we're going into our first coast down program for WLTP in March, I think. Yeah, about second week in March, I think we start that. Whereas the figures at the moment are simulated, but they're not simulated WLTP. They're simulated real world with all the power losses of real world as well. So hopefully we'll end up fairly similar, if not better, on WLTP. But for those of you who know, even WLTP is not particularly great in terms of real world. It just lets us compare ourselves with our competitors. But yeah, a fully loaded bus on steep hills is going to be interesting and does form a reasonably large part of our durability program and sort of gradability requirements of the motor systems that we've got as well.
Mm-hmm. And relating to the onboard system, so the HVAC system on the buses, and that being a big restriction on range. So have your adopted any alternative technologies there to save energy?
Yes, I think we've got a relatively novel HVAC solution, which I'm not an HVAC guy, so I can't tell you too much about. But it's HVAC's a huge problem, especially when you go to other markets where so we've been dealing in the Middle East a little bit, and in the Gulf states they have a requirement to keep their bus cabin at 22 degrees plus or minus 2, which when it's in the UK that probably means you have to warm it up a little bit, but in the Gulf states, when it's sort of 45, 50 degrees outside and you've got solar loading and stuff, it's going to be potentially a huge energy draw. So, those guys are looking at it and are, open to things like opportunity charging en route, where it will charge at various bus stops around the route and stuff. But it does change it somewhat. And, I think, a lot of the bus industry is looking at hydrogen fuel cells as a solution to help with this, because with buses you're actually relatively limited on space. Although they're massive, you still only got a certain amount of space where you can put batteries and energy generation and stuff. So we can't just add more batteries because there isn't room to add more batteries. And the more batteries you carry, the more energy you spend carrying the batteries and stuff. So we're looking at hydrogen as a possible solution as well. So and I think it's one of those technologies that actually probably over the last 6 to 12 months has gained quite a lot of gained quite a lot of momentum, I think. And actually when you're looking at fleets, it's and you can concentrate the infrastructure that you need to support it in one place. It's a pretty reasonable proposition, providing you can get the cost of hydrogen down.
Well, yeah, indeed, yeah. I guess we've seen the news stories about buses on the continent that are unable to, electric buses, but are unable to go out on their routes because of the freezing cold weather, affecting the state of charge. So I guess with the different technologies available, that it means you're quite nimble. I think you mentioned the word earlier, nimble and able to adapt to the different needs.
Indeed.
All right, I'll combine a couple of questions here that relating to composite materials and the complexity of manufacturing, the recyclability, and would it not be better to use standard press steel body panels rather than the composites? And would that not also give you a more reliable supply chain?
Potentially, yeah. I guess potentially it would, but I think the costs of developing that supply chain are, we're too big, and the weight penalties you went for that, didn't let us deliver what we needed to in terms of payload, especially on the van. But the composites we're using, so we're not. I suppose we're relatively fortunate. Is when you say composite, people immediately think of carbon fibre, which is, or Kevlar, or various composite materials, which are incredibly expensive. However, we're using the PPF composite, which isn't incredibly expensive, but you can still get a lot of the strength benefits out of that. So we're going down a cost-effective route, but we're fortunate in that when people think composites, they think expensive, which is quite a nice position to be in. You're not having to persuade people that it's the right solution.
Yeah. Okay. Question on vehicle dynamics here. So, do you do all the vehicle dynamics design and tuning work in house?
We do indeed. So we've got it's amusing. We continually have to remind some of our vehicle dynamics guys that the vehicle they're working on is a 12 metre, 8-ton bus that's fully laden is 16 tons, not a high-end sports car that's the best part of 1,200 kilograms. So we've got we've got quite a few guys who come from other UK OEMs where those vehicles are more common, And so, yeah, we're continuing having to remind them that it's a bus and it doesn't necessarily need to drift around corners with ease.
It's amazing what dynamicists will come up with as a test.
Indeed, but they're doing all of that tuning and development in house, though, definitely.
Excellent. So relating to something you just mentioned there about the weight of the vehicle there, how do you reconcile a quest for increased range or autonomous running time with more battery modules and the impact on reducing usable payload?
So I guess within our, certainly within the van product, we've got a scalable, because we use those high voltage battery modules, we can actually scale them fairly easily so we can have anywhere between 10 and 36 modules in the vehicle. So what we try and encourage everyone to do is to right size the battery pack for what they want to do. So, those much larger battery packs are aimed at people who perhaps have an auxiliary load on the vehicle, such as a refrigeration unit or something like that. So, food delivery where they need that. Because actually, most of the data we've seen is that the average daily mileage, especially of the sort of the big fleet guys, is about 60 miles a day. So, another advantage of working with fleets is they know exactly what their average daily mileage is, and they tend to have a mixed fleet where they can have other vehicles that, if they've got one route that is perhaps 120 miles, they can make sure that the right vehicle is on that fleet rather than, stock the entire fleet with vehicles that can do that. So it lets them sort of right size their battery pack to give them, so if you've got the smallest battery pack with a range of, 100, 120 miles, that should be absolutely fine for the majority of what you need, but you can also, scale upwards as, in sort of any increments that you want to.
Yeah. Would you give the operator the ability to scale up if they needed to, or would that purely be at your end in the size of the vehicle? So I'm thinking of the battery configuration.
Yeah, not initially, but it's been designed so that can be the case. So if one operator then sells it to another operator, or any operator who says, actually no, now I need more range, the vehicle's been developed so that actually that can be added fairly straightforwardly.
Okay. A question sort of quite related to your area of expertise here. So if the buses are intended to be first in service, have they been type approved? And then similarly, will the vehicles have a towing capacity? So will they be certified to tow as well?
The van won't be certified to tow initially, because at 4250 they're not allowed to tow. That was one of the first vans we produce will be at the 4250 limit. But then the 3.5 ton ones, ultimately, they will have the capacity to tow, but probably only an unbraked trailer, which is up to 750 kilos. Okay. Oh, and the other one's about bus certification, wasn't it? So that bus certification is this summer.
Right. Okay.
So for testing prototypes, we don't need to fully type approve our vehicles. So that'll be taking place sort of Q2, Q3 this year, and then the certification program starts in Q3.
And as a new vehicle manufacturer, then has that been an easy process for you to work through, or has it caused any hiccups or headaches along the way?
The obvious answer is, luckily the certification guy knows his stuff. But no, it's been fairly reasonable. As there's a lot of knowledgeable people out there, and whilst a lot of our guys don't have a lot of automotive experience, because we didn't want to be an OEM, so we purposely recruited guys who didn't have automotive experience. We've got enough people with enough experience in the right areas that actually it's relatively painless. The hard thing and the super interesting thing for me is that you take something as on the face of it, I guess, mundane as reading regulations and stuff, and you then try and apply that in the arrival way. So how do we automate that process so that an engineer doesn't need to sit there and read read the technical bit of the, so we can give the engineer the requirements, say, here you go, this is what you need. But, that's quite a painful process to do that. You have to open the regulation, you have to pull out the right bits. And how can we automate that process in, what we call the arrival way to make it as easy as possible for him to, or her to get those requirements out and be able to design to them. So, we've got a project with our software guys at the moment to get all of that information systemized, where we take a live feed from websites who do all the updating of regulations. So they all get updated on a relatively frequent basis, but we do that, and then we apply a machine learning algorithm to that regulation and pull out the bits that are the technical requirements and pull out the bits that are the test conditions, so you can present those to the right people at the right time. And sort of in the sort of typical 80-20 rule, we can probably get rid of 80% of the legwork that way, so that the 20% is actually the complicated bit of at what point are we classed as kneeling and at what point are we classed as ready to drive, and can we hit those floor height requirements at the right time in that process and stuff. Okay. Which all of that tends to be the grey area of the regulation, which is the unwritten bit.
It's interesting to hear that you're applying the novel and innovative ways of working even down as far to that level. It's quite refreshing to hear.
Yeah. Luckily, we've got an executive chef at arrival who's putting the restaurants into our sort of London HQ building, which is it's in West Kensington, which if you live in West Kensington is a really sensible place to put your headquarters. And Dennis lives in West Kensington, so it's quite handy for access to public transport and stuff. But I've yet to see whether the chef is automating his food production process yet. So as soon as lockdown in the office, I'll be back in to make sure. From what I've seen so far, if he has, he's got some amazing robots.
Well, we'll wait for that news to come out then. Okay, we've probably got just time for a couple more questions, so I'll just grab a couple because there's been plenty of questions coming through. So thank you, everyone. How challenging has it been to persuade the market to move away from their existing suppliers towards a brand new company and product? And do you find customers are often more attracted to purchasing retrofitted versions of existing products through their established relationships?
The answer is relatively surprising in that it's been relatively easy. Again, working with fleets is great because you don't worry about the emotional side of a purchase that you do when you're dealing with, when you're buying a car, for example, that's your own vehicle. With fleets, all they're ultimately worried about is cost and the bottom line. And because we've got such a novel offering in getting price parity with diesel vehicles, it's they're pretty much beating a path to our door, which is a fantastic position to be in. And the hard bit is now making sure we can deliver that. But yeah, so it's been relatively straightforward. A lot of the fleets all have trial requirements. So they won't buy vehicles off you until they've trialed them to make sure that they do what you say they do and stuff. And that process will be going on over the next sort of 6 to 12 months with van before we hit production, where they'll be trialing prototype vehicles and that sort of thing. But certainly so far, because the numbers work, it's been pretty straightforward.
Okay. Well, this will be the last question now. What steps are Arrival taking towards creating safe vehicles for both drivers and other drivers? So you may know the person who asked the question there.
Question from Thatcham, where I spent some good years running their crash lab and ADAS testing. So we are gunning for a Euro NCAP platinum rating for our van, which is the Euro NCAP recently brought out a van safety rating scheme, which comes back to the sort of the crash point I was talking about earlier, where they've all of the crash data that they can find shows that with commercial vehicles and certainly so vans and anything bigger, you're much better off in terms of the occupant protection of the vehicle that we're talking about. So, the arrival van and the protection of the people in the vehicle you might hit to try and avoid it in the first place. So what they're really looking to do is push ADAS technology onto commercial vehicles, which traditionally it tends to be a sort of a stream down from high-end cars down to medium-end cars down to, the lower-end cars at the bottom of the market. And then it hits commercial vehicles in terms of vans and stuff like that. So, we will have standard fit for pretty much every ADAS safety feature that's required on the market, and some that aren't required as well. So, and then the additional sort of driver support comfort systems as well we've got available. So things like adaptive cruise control. And sort of lane centering systems are also available, but we're all of that is a standard fit rather than an option, and there's no complexity of having to work out whether it is fitted or not fitted. And what we know from fleets is that they don't, if they can not tick an option, they'll not tick it, because it means their capital expenditure is lower. And by making it all standard fit, we sort of drive that safety into the market as well.
Okay. I'd love to keep asking the questions, because they've been coming in almost quicker than I can ask them and you can answer them. So there's clearly plenty of appetite to hear from you again, Nick. So I think we certainly will be inviting you back. You've given us a really nice overview, as I said, of the company, where you want it to be. You mentioned that your founder said you want to be a $10 billion company, and you're now about to be, valued at $20 billion. You've shown that with the sizing of the company and how you've built it up from every different aspect, like we even mentioned about looking at the vehicle certification processes and looking at the legislation. You built the company to be scalable to suit the economic conditions and the conditions that your engineers are working in. So it's really nice to see that level of innovation throughout the company. So thank you very much there. So on behalf of the IMechE, on behalf of the Automobile Division Yorkshire Centre, and also on behalf of the audience, we normally like to end with a round of applause, but unfortunately with the virtual world we can't do that, so we'll just have to have a virtual round of applause. Thank you very much for your presentation. It's been fascinating. You've dropped little tidbits of information that have left certainly me and by the looks of the questions, the rest of the audience asking and wanting more. So thank you very much indeed.
No worries. It's been a pleasure.
That's great. Thank you also to the IMechE for hosting this, and for Emma Painton behind the scenes for running things and making sure that we don't click on the wrong buttons. So thank you very much, everyone, and thank you very much for the audience and for all of your excellent questions. It's been a very, very great event. Thank you.
Thank you.